Hi everybody. Today we're going to start talking about the conservation of momentum. Up until now, we've been talking about one object, how to calculate its momentum, how to calculate its change in momentum when a force is exerted upon it. Now we're going to start looking at multiple objects, when they interact or collide, how they can exert forces upon each other that will change the momentum of each of the objects. So our objectives for this lesson are to explain the law of conservation of momentum, to solve problems using the conservation of momentum, and to finally differentiate between different ways that objects can collide. And we're going to call those elastic and inelastic collisions. You might remember when we started talking about impulse, we utilized Newton's second law to help us out. Well, when we start talking about collisions of objects, we're going to use Newton's third law to help us out. Remember from Newton's third law, it tells us that when objects come in contact with each other, they exert equal but opposite forces on each other. Meaning if two objects come in contact, object 1 exerts a force on object 2 that is equal in size to the force that object 2 exerts on object 1. They're just in opposite directions. If we take only those two forces into account as the forces that are being exerted on the objects to cause the change in momentum, and we realize that the time of collision for each of the objects in the collision is the same, that tells us that the change in momentum before and after the collision has to be the same. Because if you remember, change in momentum equals force times time. The size of the force is the same, the time is the same, so as a result that tells us that the total momentum of the system must stay the same before and after the collision. That's the basis of the law of conservation of momentum, which tells us that the total momentum of a closed, isolated system is conserved if no external unbalanced forces act on the system. We'll get to what some of those words mean in a second. First, we just want to look at it mathematically. The law of conservation of momentum tells us if objects collide, the sum of the momentum of all the objects before the collision has to equal the sum of the momentum of all the objects after the collision. It doesn't mean the motion of each individual object will not change. That can happen. We just want to know that mathematically, whatever we have before is what we have after. If we look at that a little further, we realize that, say for example, we had two objects. We took the momentum of the first object plus the momentum of the second object before the collision. We have to know that the momentum of the first object plus the momentum of the second object after the collision has to equal. Let's look at some of those other words. What is a system? For us, a system is going to be two objects. A system can be two or more objects, but we're only going to look at two objects in our types of collision. What is a closed system? A closed system is one in which neither of the objects lose any mass. So if you think about a car collision, none of the parts of the car can fall off during the collision. The masses of the cars must be the same before the collision as they are after the collision. What is an isolated system? An isolated system is just one in which the only forces that are being exerted on the objects to change their momentum are those Newton third law forces, the force that one exerts on the other. We can't have any outside unbalanced forces being exerted on our system of objects, meaning we can't have friction, we can't have any additional applied forces being exerted on one or either of the objects during the collision. Now, you all know that there are forces being exerted on the object that are outside those Newton third law forces. One of them is gravity, but you have to remember that there's a normal force when we talk about the motion that we're going to talk about, balancing that out. So that's where you have to make sure that you understand that it's no unbalanced forces external to the system. What type of collisions are we going to look at? Well, the first type of collision we're going to look at is one in which one or more of the objects are in motion before the collision. They collide. The objects stay separate as objects after the collision, but they move off in the same direction as either one or both of the objects prior to the collision. Think about this as a rear ending of a car. There's a car at a stoplight, and a car comes up behind it and rear ends that car. Both of those cars are going to move off in the same direction as the car that did the rear ending prior to the collision, and they're going to stay separate, but both of them are going to change their velocities. The second type of collision is again where at least one object is in motion before the collision, but after the collision they stick together and act as one. That means that after the collision you really only have one velocity because they both move with the same velocity after the collision. This is the car rear ends the car at rest at the stoplight, but they stick together and they act as one car coming out of the collision. The last one is one in which objects are both in motion prior to the collision, but they're traveling in opposite directions. What happens after the collision is they still stay separate, but essentially they bounce off each other and move in opposite directions after the collision than how they were traveling before the collision. And this is how we're going to classify those collisions. Collisions are going to be considered elastic if the objects do not travel as one object after the collision, meaning they don't stick together. So be it one object is in motion, both objects are in motion, they travel in the same direction after motion, or they travel in opposite directions after motion, the fact is they are still two separate objects. So as a result, we're going to call those elastic collisions. Collisions are going to be considered inelastic collisions if the objects stick together and travel as one object after the collision. You'll see these as car crashes when the cars stick together and travel after the collision as one unit. Or think about when football players collide on the playing field and they sort of hold on to each other after they collide and move together as one unit. Those are going to be inelastic collisions. The most important thing you have to remember coming out of conservation of momentum, though, is that it is based on velocity. When we start talking about these types of collisions and trying to predict the motion of those objects, you really have to make sure that you take the direction of the velocity into account. So you're going to have to make sure you know which direction is positive and which direction is negative. Because remember, we're summing up the momentum before and afterwards. So it's going to make a big difference whether an object has a positive momentum because it's moving in the positive direction, or a negative momentum because it's moving in the negative momentum. Because remember, when we add numbers, positive and negative signs do make a difference.